Okay, let's look at the law of sines and see how we derive this. The law of sines is very simple. And I'm going to show you how to derive this just from the information that you already know, okay, from high school. Math is very easy or simple. And math is very easy if you study. But this is where all the failure begins. The majority of math is derived from the math that you already know, so it's easy to remember. To demonstrate this, let's derive the law of sines. The law of sines is used when you know two angles in the side. Let's see how to get the law of sines. What is the equation for the area of a triangle? This is something everybody knows, right? Let's draw a triangle. We have angle A, angle B, and angle C. We have triangle A, B, C. So, look how I got this triangle. Watch how I got this triangle laid out. I have angle A, and opposite angle A, I have side A. Angle B, and opposite angle B, I have side B. Angle C, and opposite angle C, I have side C. And from the vertex, I've dropped an H, a perpendicular, I call that H, as the height. That represents the height of the triangle. And this little square here on the H says that this H is perpendicular to the base, okay? And that makes this two triangles, two right triangles. And if we have two right triangles, that means we can use our trigonometric functions, sine, cosine, tangent, and so forth, which I'll probably talk about in another slide. Okay. The area of a triangle is equal to 1/2 the base times the height. The base is C, and the height is H. Okay. Well, we don't know what C is, and we don't know what H is. So let's look at this. Also, sine of angle A, the sine of angle A is opposite leg over the hypotenuse. Well, what's the opposite leg? The opposite leg is H. The leg that's opposite angle A is H. And the hypotenuse is the longest side, which is B. Okay. So sine A is equal to H over B. And if I multiply both sides of this equation by B, I'll get B over B cancels, and that's equal to B times sine A. So H is equal to B times sine A. So in our previous calculation where we had area is equal to 1/2 C times H, and we just calculated H is equal to B times sine A, so we substitute that into our equation for H, and we get 1/2 area of this triangle is equal to 1/2 C times B times sine A. Let's continue. Now let's take a closer look at the previous operation. We have the area of this triangle is equal to 1/2 C times B times sine A. That means the area of the triangle is 1/2 times the two legs and the sine of the angle between them. The two legs, C and B, and sine of the angle between them. The angle between C and B is A. If that's true, then maybe we can do the same thing for the other angles. So let's try angle B. Okay, so angle B is the two legs are A times C, or C times A, and the angle between the two legs is angle B. So the area is equal to 1/2 C times A times sine B. Okay, let's take the next angle, C. Well, the area is equal to 1/2 of the legs multiplied, A times B, and the angle between them is C, sine C. So the area is equal to 1/2 A times B times sine C. Okay, notice that all of these areas we calculated are equal to each other. Every angle area we calculated is equal to each other. Notice also a unique feature about how we label a triangle. The leg A is opposite angle A. Leg B is opposite angle B. And leg C is opposite angle C. Now, I don't have to do that, but it's really nice if you can do that because it makes it easier to understand. But you don't have to call these angles in here angle A. I could call this angle something else if I choose to, okay? But I do it this way for these videos in the beginning so you can learn that this can be done. Okay, let's continue. All of these formulas represent the area of the same triangle, as we saw. So let's put them equal to each other. So the first area we had was, so the area is equal to 1/2 C times B times sine A. That's of the first angle we use. And that's equal to 1/2 C times A times sine B. And that's equal to 1/2 A times B times sine C. They're all equal, as we stated before, because they were all equal to area, okay? And so we just put one area and put them equal to each other. Now, let's divide each expression by 1/2 ABC. Divide 1/2 ABC into each one of these. If I do that, 1/2 ABC into the first term, well, 1/2 divided by into 1/2 is 1, so that cancels. BC divided into BC cancels, that's 1. So that just leaves me A sine A over A. The next term, if I divide this into the next term, that leaves me sine B over B, because A and C cancels. And if I divide this into the next term, I get sine C over C. I divide each expression by dividing out each equal terms. This is the law of sines. Nothing new, nothing you didn't already know, derived from the area of a triangle. Let's solve a problem. Two forest ranges are miles apart from each other on a straight service road. Both rangers sight an illegal bonfire away from the road. While talking on the radio, they determine the fire is between them. Ranger A line of sight to the fire makes an angle of 38 degrees with the road. Ranger B line of sight to the fire makes an angle of 63 degrees with the road. How far is the fire from each ranger? Let's draw a diagram. Okay, so we draw a triangle here. We have Ranger A, Ranger B, and here's the fire, the red at the top. Okay, the question said, Ranger A line of sight to the fire makes an angle of 38 degrees. And so there it is. We draw a line 38 degrees to the fire from Ranger A. Ranger B line of sight to the fire makes an angle of 63 degrees with the road. So we draw a line 63 degrees to the fire from Ranger B. Okay. How far is the fire from each ranger? Okay. So what we do is we drop a perpendicular down to the base. We do this so we can use our trigonometric functions. Okay. And we also see that from Ranger A to Ranger B is 12 miles. It says in the question, two forest rangers are 12 miles apart from each other on a straight service road. Okay. Now, let's find angle at the top of this triangle. We know this is a right angle, and we know this angle is 63 degrees, but we don't know what this angle is. Okay. So, but we do know that triangles have 180 degrees in their angles. Their angles sum up to 180 degrees. So if we know this angle, and we know the 90-degree angle, we can subtract that from 180 degrees, and we get 27 degrees for this angle. Okay. Now for the next angle, we know this triangle on this side has 180 degrees. So we subtract 38 and the 90 from 180, we get an angle of 52 degrees. Okay. So the sum of these two angles, the top angle is equal to 52 degrees on this side and 27 degrees on that side, gives us 79 degrees. So the total degrees in this one triangle, A, B, and the fire up here, if we get 38 plus 63 plus 79 is equal to 180. Okay, let's continue. Okay, let's use the law of sines to find side B. Okay, now we found all of the angles in the triangle. We got 38 degrees, 79 degrees, and 63 degrees. Okay, and we have two ranges. We have range A and B 12 miles apart. Okay, so let's use the law of sines to find side B. Okay. Now, we have angle 79 degrees. Let's have the 79 degree angle. Sine of 79 is opposite the 12 miles. So, sine of 79 is leg opposite 79 is 12 miles. That's sine 79 degrees divided by 12. And we have that's equal to the sine of 63 degrees, and the leg opposite 63 degrees is B. But we don't know what B is, okay? So then we multiply each side by B and divide each side by sine 79 and multiply each side by 12. We come up with B equals sine 63 degrees divided by sine 79 degrees times 12. And if we do that, we have B is equal to 10.9 miles. Okay. Now, how do you find the sine? Well, the sine is on your scientific calculator. If you have a scientific calculator, you see SIN, sin. And so, however your calculator works, they all work differently. In my calculator, if I put 79 degrees, 79, and I press the sine, it'll give me 0.9816. Okay. And then, if I put 79 degrees, and I press sine, it'll give me 0.9816. And what did I do? 63 degrees. Sine 6 degrees. It'll give me 0.891 for 63 degrees. Sine of 63 degrees. And for the sine of 79 degrees, it'll give me 0.9816. And then if I multiply that by 12, I'll get 10.98. Okay. And let's do the 38, angle 38. So we have sine of 38 degrees, and the opposite of sine, the leg opposite sine 38 is A. And we have sine 79, which I would use that again, is the leg opposite that is 12. So if we do our multiplication and division to get A on one side by itself, we have A is equal to 7.53 miles. So Ranger A is 10.9 miles from the fire, and Ranger B is 7.53 miles from the fire. Okay. Okay, let's solve one more problem. Well, this is a doozy here. Let's find angle rho. Okay. Now this is the question here. A lighthouse is located on a rock at a certain distance from a straight shore. The light revolves counterclockwise at a steady rate of 1 revolution per minute. As the beam revolves, it strikes a point on the shore that is 2,000 feet from the lighthouse. 3 seconds later, the light strikes a point 750 feet further down the shore. To the nearest foot, how far is the lighthouse from the shore? Now, the reason why I gave you this is because this is where most people flunk algebra in word problems. Well, word problems are just straight life problems, you know. Suppose you were on a shore and you had to determine how far a lighthouse was from a shore. Well, this is the kind of word problem you would have. And so you would have to set it up to where you can find the distance. Okay. So that's why I give this to you. And it's not very difficult. We're going to walk through this. Okay. So let's draw a diagram. Okay. So we have a diagram. We have the shore here, B, which is called B, the shore, and we have the lighthouse up here. Okay, and it says a lighthouse is located on a rock a certain distance from a straight shore. Here's a straight shore, and here's the lighthouse. The light revolves counterclockwise at a steady rate of 1 revolution per minute. Okay. It doesn't care. It doesn't matter whether this light revolves counterclockwise or clockwise. But it tells you that. But it doesn't matter. What matters is that it revolves at a steady rate of 1 revolution per minute. And I put these in red. Okay. As the beam revolves, it strikes a point on the shore that is 2,000 feet from the lighthouse. And there it is. 2,000 feet from the lighthouse. Here's the lighthouse, and point D is the point it strikes 2,000 feet. So that's 2,000 feet. Okay. And it says 3 seconds later, the light strikes a point 750 feet further down the shore. And that's point C. So from D to C is 750 feet. So to the nearest foot, how far is the lighthouse from the shore? Okay. And that's what we got to do. Okay, so let's continue. We're going to use, this is our law of sines. We're going to use that. Okay. And we're going to determine these angles. Theta, as I said before, you don't have to call these angles A, B, and C. So I'm calling this angle theta, and I'm calling this angle, the next angle here, rho, and the bottom angle I'm calling beta. These Greek symbols, okay? That's the Greek alphabet. And these are the symbols I'm using, okay? Okay, number 1. Because the lighthouse makes 1 revolution every minute, it says up here, 1 revolution per minute. The angle the light revolves is what? We have to find this angle, okay? And how do we do that? Well, 1 revolution per minute can give you that. And I'm going to show you how to do that. 1 revolution per minute, okay? We got to eliminate minute, okay? So what is 1 minute is equal to what? 60 seconds, right? So we have 1 minute on top, 60 seconds on the bottom. Well, minute over minute cancels, okay? So now we have 1 revolution per 60 seconds. Okay. Well, how do we get rid of revolutions? Well, we got 360 degrees as 1 revolution. Okay. It's 360 degrees on the top is per 1 revolution on the bottom. Well, revs cancel. Okay. And now, how do we get rid of, so we've gotten rid of minutes. We've gotten rid of revs. And now all we have left is seconds. How do we get rid of seconds? Well, it says 3 seconds later. So we multiply by 3 seconds. And 3 seconds cancel, and we're left with what? Degrees. And we say 1 times 360 divided by 60 is equal to, times 3 is equal to 18 degrees. Okay. So if you take 360 degrees and you divide that by 60 and you multiply that by 3, you get 18 degrees. Okay. As we have there. So rho is equal to 18 degrees. So we got that first angle. Let's continue. Okay. Number 2, use the law of sines to find the angle beta. Okay. Now, we're familiar with the law of sines because the sine of angle beta is what? The sine of angle beta, what's the leg opposite angle beta? 2,000 feet. Sine of beta is 2,000 feet. And the sine of rho, what's the leg opposite rho? 750 feet. Okay. So the sine of beta divided by the leg opposite angle beta is 2,000 feet, and the sine of rho and times divided by the leg opposite rho is 750 feet. What is rho? 18 degrees. Okay, so if we multiply each side of this equation by 2,000, we get sine beta by itself. So we get sine 18 degrees divided by 750 times 2,000. Okay, and that leaves us with sine beta is equal to 0.8240. And now to find what beta is, okay, you just click the arc sign, which is below the sign on your calculator. And so and on my calculator, I hit the shift key and then sign, and it gives me 55.49 degrees. Okay, let's continue. Okay, let's find the angle theta. So we got these two angles, rho and beta. Now we got to find angle theta. Okay, let's use the triangle measure to find angle theta. Okay, well, angles in a triangle we know are 180 degrees. Okay, so these three at the top are equal to 90 degrees. And this one, the right angle is equal to 90. So 90 and 90 is 180. So these three angles, theta, rho, and beta, has to be equal to 90 degrees. Okay. So we have theta plus 55.5 plus 18 is equal to 90. So if we subtract 55.5 and 18 from both sides of the triangle, from both sides of this equation, we get theta is equal to 90 degrees minus 55.5 degrees minus 18 degrees. And that gives us theta is equal to 16.5 degrees. Let's continue. Now, let's find the distance C from the lighthouse to the shore. Right here. Well, this is simple trigonometry here. The cosine of theta is equal to the adjacent leg over the hypotenuse. Okay, and we already know what theta is. Theta is equal to 16.5. So cosine 16.5 degrees is equal to the adjacent leg, AB, over the hypotenuse, AD. So we know AB is equal to C, and AD is equal to 2,000 feet. So if we multiply both sides of this equation by 2,000, we get C by itself. So C is equal to cosine of 16.5 degrees times 2,000. So on your calculator, on my calculator, I put 16.5, and then I hit the cosine, cosine, COS, and that gives me 0.958819,734. It keeps going. Then I multiply that by 2,000, and that gives me 1917.6 feet, which should be less than 2,000 feet. And that's right. That's the answer. Let's continue. Okay. Here's a list of the Greek alphabets I used. Okay. Alpha, beta. If you go all the way down here to rho, you have a rho, which I used. In engineering, we use these Greek alphabet symbols. Okay. This is the alphabet. Here's the symbols we use. And so I can call angles whatever one of these I want to. You know, eta, theta, iota, kappa, lambda, mu, nu, and psi, pi, which you should be familiar with pi, and sigma, chi. Chi is used in statistics. Okay. Okay, I enjoy making this. The business loves math. It's not magic, it's the law, and you should too. I hope you enjoyed this video. I hope you learned something. Next time, I'm going to do probably the law of cosines. And then I'll do a trigonometry video. So, until next time, I hope you learned something. Thank you.